All right, so this should go fairly quickly. Let's talk about your electrolytes. This is just giving you the basic overview. We have a bunch of electrolytes in the body. Depending on the kind of electrolyte, they're everywhere. They're in all three compartments. You have electrolytes in the intravascular space, you have it in the interstitial space, and you have it inside all of the cells. The ratios are different, which I think we'll talk about on the next slide. And these electrolytes are incredibly important for life, for homeostasis, and keeping electrolytes balanced has to be a priority. And so on top of that, those electrolytes, we've talked about that sodium potassium pump. We've talked about action potential, and how our body uses our energy depends or has so much to do with that sodium rushing into the cell and the potassium rushing out and depolarizing and repolarizing, and all of our muscle contraction, including the heart, depends on this action. And so all of that is depending on our balance of electrolytes in each compartment. We've kind of talked about this a little bit, but the most populous, I guess, or common, the most common cation inside of the extracellular fluid. And again, extracellular includes your vascular spaces, so your blood, let's put blood, and your interstitial. So anything that's outside of, right, outside of the cell, that is a lot. What's causing that oncotic or that osmotic gradient outside in the extracellular space, right, is going to be sodium. The opposite is inside the cell. Sorry, let's look at intracellular. Then the most common cation is potassium. And if you think about action potential, and I'm going to use this area, things rushing in, or sorry, arrow, and things rushing out, you know that it's a lot of sodium outside and a lot of potassium inside to start off, and then the sodium rushes in, the potassium rushes out, we have action potential, blah blah blah, right? I wouldn't worry as much about these anions. For you guys, you're very lucky because it doesn't look like you go into a whole great deal. If I were taking the test, I would just kind of go phosphate, I would probably just line up phosphate and potassium so they both start with a P, and remember that those are both intracellular, and then everything else would be extracellular, and leave it at that, because you guys aren't going into hyperphosphatemia or anything like that, so you're good. And we'll talk about bicarb next week. So I'm just looking at these, we're kind of looking at the slide, trying to figure out what they're trying to say. We covered this. I think it's a lot of repeat here. Electrolytes are small, inorganic, charged particles. I guess I've been calling them cations, right? I've been saying that normal saline and potassium are cations, and that's because they're atoms that are, or molecules that are positively charged. We're not going to go into how that happens and why that happens. But we also have anions, and those are negatively charged. If you look back on this slide, you'll see that we listed cations and anions for each one. I'm just telling you, sodium and potassium are the ones we want to focus on for this unit.